Hey everybody, it's Jenny from Norman S. Wright. In the last couple of weeks, I've covered chill beams and underfloor air distribution. So today I want to cover displacement ventilation, which is the third of the green or sustainable systems that originally came over from Europe. So let's get started.
A displacement ventilation system is defined by ASHRAE as a fully stratified system. This means that there's no mixing in the occupied space. Looking at how displacement ventilation systems work will explain why it's a fully stratified system. In a displacement ventilation system, the supply air is brought in close to the floor and at low velocities. As this supply air travels across the floor, it displaces the warm air in the space. And since the supply air isn't mixing with the room air, you end up with a stratified layer of warm air sitting on top of the colder supply air. And this is what you want to happen because you don't want to have to pay to cool the top of the room because no one is up there. Let's move this over to make some room. Like the underfloor systems that I talked about last week, because you're supplying air directly into the occupied space, the supply air temperature is warmer than what you would use in an overhead system. In an overhead system, the supply air has to leave the diffuser and travel across the ceiling and roll the room before it gets into the occupied space. So we use 55-degree supply air so that when it rolls the room and mixes with the warmer room air, it ends up a comfortable 75 degrees in the space. In displacement ventilation, the air goes right into the occupied space, so you don't need to start as cold. Displacement ventilation systems use 60 to 68 degree supply air. The low velocity is important since this is a non-mixing system. In an overhead system, the face velocity of a diffuser can be 400 to 500 feet per minute. In a displacement ventilation system, it's usually 50 to 90 feet per minute. The cold air will slowly leave the diffuser, and because it's colder than room temperature, it will fall towards the floor and travel along the floor into the space. When the supply air comes to a heat source, like a person or maybe a computer, the heat will cause the air to rise, and this convection plume pulls supply air up across the person, providing them comfort and fresh air. And the heat will rise into the stratified layer. Let's make some more room. ASHRAE Standard 62.1 also gives displacement ventilation systems a ventilation effectiveness of 1.2, meaning that you can reduce the amount of fresh air you need to bring into the occupied space to meet requirements. You still have to remember that even though the supply air is warmer and a low velocity, you don't want to have greater than 40 to 50 feet per minute in the occupied space. So if the diffuser is supplying air at 90 feet per minute, you'll have an area that cannot be occupied called the clear zone. This is something you need to consider when you look at diffuser and furniture layout because you don't want the clear zone to be so big that you lose much of your occupiable space on the floor. Let's move this up a little. You also want to make sure that you're supplying enough air for the whole space. A good rule of thumb is to select the diffuser so that the furthest end of the space, the velocity is about 15 feet per minute. That's about when your supply air is used up. Displacement ventilation diffusers look like large perforated diffusers, but they're mounted in a wall or sometimes a column. They're very quiet diffusers, which makes them good for schools. They can also have adjustable nozzles behind the perforated face to allow control in the direction of airflow, so you can make some adjustments to the air pattern to suit your space. So let's bring everything back on screen. So that's an overview of displacement ventilation. If you have any questions or topics you'd like me to cover, leave a comment below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.